Ladies and gentlemen, hello. I hope you are doing well. I'm very pleased to present to you my work, Design and Manufacturing of 3D Printer Filaments Extruder, which is for me a worthy challenge and a great pleasure. In this perspective, I will present this work according to the following plan. I will start by introduction, then our problematics, methods and materials, and we will see after the overview of results, and we will finish by a conclusion. The 3D printing technologies are widely used for the production of polymer components from prototypes to functional structures with difficult geometries. By using fused deposition modeling, it can form 3D printed through the deposition of successive layers of extruded thermoplastic filaments. The 3D printing can create physical objects from a geometrical representation by successive addition of materials. It is also a manufacturing technique to produce components in 3D using computer-aided design. Because of the expensive price, permanent mechanical properties and chemical composition of the filaments, and also the useless waste plastics, a new solution is about extruding the raw materials of the 3D printer, starting with computer-aided design software for all parts and finishing by realization of the test bed. However, this is about creating and producing the filaments used, for the purpose of studying the mechanical properties of materials, making the raw materials available immediately, reducing the price of the filaments used in 3D printer, and recycling waste plastics. The extruder is a long continuous process of the polymers. It's used to produce tubing, tire treads, and wire coverings, so it pushes the raw materials into a heated tube heated by two heaters fixed in the external side of the tubes. The pushing process uses endless turning screw turned by a motor, then compressed into a shaping die which is used to extract the final product as a filaments of 1.75 and 2.5 millimeters. So starting with the design using computer-aided design software, then fabricating the parts using mechanical turning machine, mechanical milling machine, the laser machine were used to perforate the shaping die with high precision of 1.75 and 2.5 millimeters. So the pictures show polymers, polyurethane and polycaprolactam, which we use in the study. So the polycaprolactam has poor resistance to ultraviolet, hence additives like 100 amines provide light stabilization and enhances the service life as compared to unmodified. Well, so here we see the turning screw used has 16 millimeters in diameter and 150 millimeters as a total length, assures the transfer of thermoplastic materials in order to be extruded in different final forms aimed, thanks to its rotation around its axis of revolution and the geometry of the flights which have 20 of width for each, while fixing the pitch in 43.5 millimeters between each two successive flights with 6.05 of channel depth. Okay, so we will pass now to see the steel tube which works as a chamber housing for the screw. The raw material is fed into the chamber through it. The tube used has 16 millimeters as internal diameter, 25 of external diameter, and 150 millimeters as a length, with a hollow area in the lateral surface which is consecrated for the material feed. So we are seeing now the copper tube, which is fabricated of copper material, which has a high thermal conductivity reached to 386 watts per meter Kelvin, 104 millimeters as a length, 25 and 20 millimeters of external and internal diameter respectively, to assure the fusion of the material inside by increasing its temperature thanks to heaters fixed on the lateral surface of the tube. So here is the suction hopper, which has a goal in this process. It's simply to hold the necessary quantity of the material fed to the screw. So let's see now the Perolala pipette, which made of wood for creating a thermal isolation between the hot band cold components in its two opposite sides, with three holes of 8 millimeters angularly offset by 120 degrees and 25 millimeters of thickness. Okay, so here in this experiment we will use two shaping dies. One has 1.75 millimeters of the little hole diameter and the other one has 2.5 millimeters, generally made of brass because of its capacity of withstand high temperature. Okay, so here we have the final design of the extruder, which is assembled by a computer-aided design software, while including also the electrical parts in the system, which you can consult in the presentation of my colleague Naboulssi, which is about the control of 3D filament extruder. So here, as you see in the video in front of you, which shows that the machine works perfectly, which means that we succeeded to produce the filaments with two different diameters. Okay, so here the goal of this study was to investigate the mechanical properties of the produced filaments and also the one additively manufactured parts using the extruder. So here we see the tensile testing was carried out using a tensile testing machine with a load cell of 30 kN. The crosshead speed was 10 mm per minute according to the standard, as you see in the image at right. So here we have tensile testing on the extruded filaments are undertaken based on specimen geometry of 150 mm as total length and 71.69 mm for Mondrian binding. Okay, so here we have the following graph which presents the different properties between the real PI6 one and the extruded one, which are close to each other, but just we realize that the only difference between them are because of the micro inserts in the extruded one, while also showing the mechanical behavior of each of the specimens analyzed. So as a conclusion, we can say that in this research we made a plan to design and produce the filament extruder, starting with conception on software design and ending with realization. Finally, filament extrusion's parameters have been studied. Also, material filaments have been mechanically characterized. The mechanical properties obtained in our manufacturing filament will be considered satisfactory. Time and cost has been reduced. A workflow manufacturing filament extrusion system has been developed.